All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. As we get started today, I actually wanted to show you a video clip of Despicable Me when we meet Mr. Vector, because that's exactly what we're talking about today. But unfortunately, I wasn't able to actually pipe in the sound very well from YouTube. So if you actually go to YouTube right now and you were able to, watch that video clip when Vector is introduced to us, you would actually see the description or the definition of what a vector is, okay? If you remember the scene, he talks about how it has to do with both direction and magnitude. And then he goes on there and introduces his, what was it, piranha gun or something like that? So anyways, I wish I could have shown that to you. It was a nice little clip that would have led into this, but unfortunately I'm not that tech savvy, so we'll just roll with it. Anyways, I want you to go ahead and write down these terms for me as we lead into what we're going to be talking about. And, it's really important that you understand what the connection to today's lesson is, not necessarily to geometry or math, but more or less physics. Vectors are huge, maybe even in physical science, as they talk about how forces act upon each other. But I really remember them a lot when I was a senior taking physics in school. So just a thought for those of you that aspire to take those upper level science classes, this is a term that will show up a lot in those classes. So a vector is any quantity with both magnitude, any quantity with both magnitude, and in parentheses I would put size, okay, and direction, okay? Vector is any quantity with both magnitude, which is the size of something, and direction, okay? Now, maybe I should clarify why I had you put size in parentheses. The length of a vector, which is actual ray, as we show it in our work over the next couple of days, the longer that vector is, the greater the magnitude that vector has. Okay, so you got a short little ray, that means not very much magnitude. If you have a long ray, that means it has a strong magnitude. Okay, so looking at magnitude, here's what I want you to put down. It could be a distance, it could be a speed, miles per hour, kilometers per hour, meters per second, and it could be a force. Okay. And off to the side of that, since we didn't write very much there, I would like you to write what I just said in parentheses. So in parentheses, put this down. The greater the magnitude equals the greater the vector. The longer the vector, sorry. So again, the greater the magnitude would equal the longer the vector. Okay. Now, for the direction, here's what I'd like you to write down for direction. And let me go ahead and get this going here. Oh, go back up. Okay, and always takes me a moment to get used to the technology because I don't usually use it. So if I go ahead and write out a vector, here's what we're looking at. Direction, sorry, I'm in direction. It's going to be x degrees something of something else. Okay, north of east, south of east, east of south, west of north. Okay, it can be any of those. But this first blank is actually going to be the direction you are heading. Direction you are heading. Okay. And then this blank right here is the direction you are coming from. Okay, again, the direction you are coming from. And I know as of right now, it's going to be a little awkward identifying vectors and their directions initially like this. And a lot of you may forget how to identify the vector as far as the direction is concerned. when we get to the test. So don't do that. Really try to understand what's going on with these next couple of examples. And again, we'll see that on the homework. We'll see that as we review this lesson later on. And hopefully you'll be able to fully understand what's going on. So the next thing I want to do, after you've got those three terms defined there, is to actually talk about the direction. Use compass directions to describe the direction of each vector. And so if I look at number 1, let's go ahead and write this out like we did originally. X degrees what of what? Okay, well, obviously the degrees won't be x. We're going to fill that in with 35 degrees. Okay? And where are we heading? Well, we are heading to the east. We're heading in this direction right there. We're heading towards east. So this would be east, if I can get it to go, east of, now where are we coming from? We originated from the north here on this one. So east of north. Okay? So again, so many degrees, where we are heading of where we are coming from. All right? Now, looking at number 2, let's just apply that same thought process to this problem. If I look at number 2, we are 25 degrees. What of what? Okay. Well, again, the question is, where are we heading? Well, we're heading in a southerly direction. We're heading towards the south. So I'm going to put down south right there. And where are we coming from? Well, we originated from the east here. Okay. So, again, those would be 2 examples of how I want you to describe the direction of the vectors that we're going to be looking at. Now, I will tell you this. You can describe these vectors in one other way, okay? Obviously, this is 90 degrees right here, okay? And if I take 90 minus 35, I get 55 degrees, okay? So if I was to put this down, I could also say 55 degrees what of what? Well, it helps, I think it helps students in looking at these type of problems by actually drawing in the arrows. Okay, so if that helps you, please go, by all means, go ahead and do that. But if you look here, we're heading now in a northerly direction. We're heading towards the north. So this would be, what direction are we heading? North. Where are we coming from? We're coming from the east. All right. So the directions there would be 55 degrees north of east. All right. If I do the same thing for number 2, again, 90 minus 25 gives me 65. So again, I can put 65 degrees down. Okay. And we're heading in this direction right here. So what direction are we heading? We're heading towards the east of what? Where did we originate from? We originated from the south. Okay. So 2 possible ways you can possibly do that. I want you to go ahead and try to do numbers 3 and 4 for me there on your paper. See if you can finish those up. Okay. And pause your computer because I don't want to use up too much memory here as I make the rest of this video. Okay. So I didn't actually realize this until I got done with number 1. If you look here, the 55 degrees is the same that we have over here. Okay, so your first answer could have been that right there, 55 degrees north of east. Again, we're going north of east. You can also go 35 degrees east of north because the sum is 90. So either one of those would be an acceptable way to identify that vector. Okay. Now, as far as how do we sketch the vector, okay, make sure you always start out with your compass directions. Okay. My daughters the other day told me an acronym for this. I can't remember what it was. Something about eating soggy worms. I don't remember the first part. So yeah, if that helps you to remember the directions, or you can just remember north, south, east, and west where they go. But here's what we're going to do. We have 48 degrees west of north. Okay, So this is the direction that we're heading, and this is the direction where we're coming from. So I'm going to go this direction. I'm heading west from north, up north, 48 degrees. So it should be somewhere out in a little more than half right there. Now, what I'll be checking here, guys, is this. One, make sure you have the vector in the correct quadrant. Okay, that is going to be key. Two, also make sure that you have the degree on the right side of the vector. Because if this is 42 or 48 degrees, that means that this is going to be 42 degrees down here. But this would be 42 degrees north of west, and as opposed to 48 degrees west of north. Okay? So I hope that's making sense to you how to draw that back, because we're going to apply it here in a little bit to some story problems. All right, now, in looking at the next example here, guys, let's take a look at example number 2. We want to describe the vector as an ordered pair. Now, when we say these words, ordered pair, what we're really saying is we'd like to describe it as an x comma y. Okay? Now, you'll notice there I didn't put them in parentheses. I put them in those little goofy brackets. Well, the reason I do that is because that's how it's shown in your textbook. Am I going to be really particular as far as the parentheses versus the brackets? No, I'm not. Okay? But it will be important that you put them in some sort of bracketing. Okay? So what we have to do is figure out this vector has a direction, 28 degrees. Now if I go ahead and set up the north, south, east, and west, south, east, west, the vector has a direction of 28 degrees south of west, and it has a magnitude of 48 or 42. Now we don't know what that magnitude is. You know, it could be a force, it could be, you know, we just don't know. 42 something, okay? But the key here is this. To describe this vector as an ordered pair, at the tip of our arrow is actually the point that we would like to find here. It's the x and y value, okay? So before I get going, I know that my ordered pair, being in the third quadrant, is going to have a negative x value and a negative y value, okay? If I can do that, there you go. All right, so from there, if you go ahead, we're going to use trig here. Go ahead and form your right triangle. Okay. So what we're going to do, like I said, we're going to form a right triangle to come up with the trig here. Now the tricky part, or the part that you really need to focus in on, is which part of this right triangle is going to be your x and which part of this right triangle is going to be your y. Well, if you think about it, this is any horizontal length is always going to be your x, right, along the x-axis here. So I'm going to put an x here, and any vertical length is going to be your y. So here's the y right there. So if you can figure out what the x and the y value will have to be, then you can figure out which trig function, well, you'll need the trig function to figure out the x and y value. Anyway, sorry. So if I go up here and label the sides of my triangle based off the right angle and the 28 degrees, this is obviously my hypotenuse. Here's my adjacent to the angle, because the angle's right there. And then here's my opposite side, okay? So what I would do, working forward from that point, is to go ahead and, let's say I want to solve for x. Well, I've got the angle, I've got the adjacent side, and I've got the hypotenuse. So thinking about our trig functions, so, ka, and toa, what we notice is that we've got enough to use the cosine, okay? So I'll go ahead and set that up. The cosine of 28 is equal to the adjacent over the hypotenuse, okay? Now we've been doing a lot of examples of these, so I think by now you guys have this down. You're going to form a proportion, you're going to cross multiply, you're going to solve for x. So hopefully you are good with this right here. All right. Now from there, all right, if you see me bouncing back and forth between my icon thing over here and pausing my computer over there, It's because I've had people bounce in and out of the classroom as I'm trying to make this. So anyways, like I was just saying, you know, you guys know how to solve this. You can get x by itself, and then we can go ahead and get the value of x, which if you plug that into your calculator, we'll say round to the nearest tens place, 37.1, okay? And so if I put that up there, 37.1, negative 37.1 is how far we're traveling on the x-axis right here, okay? To get the y value, I've got my opposite side, my hypotenuse, and my angle, and so I'm going to use my sine function here, okay? So if I set that up, the sine of 28 is equal to the opposite over hypotenuse, okay? Again, I'm confident you guys can solve this. You have done a good job to this point in the chapter of doing this stuff. So we get this right here. Okay, 42 times the sine of 28. Now, if you go ahead and plug that in, you're going to get approximately 19.7. Okay. Now, as I plug it back in up there, again, because it's in the third quadrant, it's going to be a negative 19.7. So again, this is negative 37.1, negative 19.7. So I guess one of the things I want to get across to you guys, I hope that makes sense to you on how you solve for both the x and y. But one of the things I want to make sure you understand is there's multiple ways to describe a vector. One way would be to use your ordered pair, as we have just done. And one way would be able to use direction and magnitude, which is, if my pen works, there you go, is that right there, okay? It does not matter which you choose to do, just make sure you know how to do both, okay? So, let's move on to the back side here of this. Okay, and here's what we have. This time you're given the ordered pair of a certain vector. Okay, so here's my ordered pair. All right. Use the ordered pair to describe the vector's magnitude and direction. So what I'm going to do, now noticing I have a negative, negative, I know it's in the third quadrant again. On all of these type of problems, what I would first do is to go ahead and draw in my compass directions. So there's an attempt to do north, south, east, and west. Okay? Now, it is beneficial if you can go ahead and appropriately draw your picture. So, and it will help out later on. So if I go ahead and do, let's say that this is 50, this is 100, negative 100, and I was going to do 50 and 100. We're out in here, you know, somewhere close, like right there. Okay. So my vector actually goes from the initial point, so this point right here where it starts is called the initial point, to the terminal point. And those two terms will actually be on your next test. Initial point is your starting point of your vector, terminal point is the ending portion of your vector. Okay? And so from there, if I go ahead and want to find the direction and magnitude, the direction, it doesn't matter which side you come from, this side here or this side here, okay? Let's say for argument's sake that I want to come from this side over here, okay? So I want to get this direction, and I'll do the magnitude later. Now, in order to do that, we have to make a right triangle. We're going to use trig to get this value. So this length, obviously, is going to be your 90, because this is the y value, okay, negative 90. It doesn't matter if you put negative or positive. Actually, let's just make them both positive. And this is going to be your 100, so negative 100 is over there, okay? But when we plug it into our trig function, you can just make them both positive. It will have no influence on the final answer, okay? So, as a result, if I want to find the direction, the question that we want to ask ourselves is which trig function are we going to use? Well, this side is the opposite of the angle, and this side is your adjacent to the angle. So as we look at the direction there, we're going to be using the tangent function. Tangent of x is equal to the opposite over the adjacent. Okay? And so from there, if we go ahead and solve for x, we should have that angle. So again, we're going to use the inverse tangent because we're solving for a degree. And we should get, let's see here, approximately 48 degrees. Okay, I believe that's correct. 48 degrees there as you work that out. Now, it'll be very important that as you get the degree there, you also get the direction. Okay, so yeah. So if I were to ask you what direction, what of what is this vector going? Again, I'm going to draw in my arrow because I think that's beneficial, that's helpful in describing the direction. The question I would ask you guys is, what direction are we heading? We're heading west. What direction are we coming from? We are coming from the south. We originated at the south. So as a result, we are 48 degrees west of south there. Okay? Now, let's say by chance you decided to go from this one over here. Okay, you wanted to get that angle. That's completely fine, but it would change just like we talked before. It would be 42 degrees south of west. Okay, south of west would be the other direction. So the second half of this problem is to find the magnitude. So in order to find the magnitude, okay, what we need to figure out is, magnitude, remember, is the size of the vector. Okay, how big is it? And so in order to figure out the size of the vector, we have a right triangle. We know two of the three sides, so I'm just going to use my Pythagorean theorem to figure out the magnitude. So we have 90 squared plus 100 squared would equal the hypotenuse squared. Okay? And if you work that out, solving for the hypotenuse length there, let's see here, 100 squared is 10,000, 90 squared is 8,100. And we get 18,100. And the square root of that is going to give you, if you want it in radical form, 181, is it meters? Yeah, we do know. They give us a unit there. Okay, so it'd be meters or 134.5 meters. Okay, so again, direction and magnitude. So hopefully that makes sense to you. Direction needs to be a trig function. Magnitude, very simple. Excuse me, just doing the Pythagorean theorem. Okay. So why are we doing all this? Well, eventually when you get to physics, you're going to be doing story problems that are more complicated than what I'm about to show you. But here's something similar to things I'm going to be asking. Not only that, but physics will probably be doing something similar to this. So a small airplane lands at a point 246 miles east and 76 miles north of the point to which it took off. Describe the magnitude and direction of its flight vector. So if the first thing I'm going to do in this problem is I'm going to go ahead and draw some compass directions, north, south, east, and west. Okay? And so as a result, I've told you this before, I think it's beneficial to make sure that you go ahead and draw these somewhat accurate. And so if I go ahead and make that this is 100, we'll say this is about 200, okay? 246, I will say, is 246 miles east. We'll say it is right about right there, okay? And then we want to go 76 miles north. So the initial vector that they gave us was 246 miles east. and then 76 miles north. Now, if this length right here is 100, I'll go ahead and mark that out. So right about right there. Okay, doesn't look quite, but I tried. So 76 miles would be 3/4 of the way up. So if I go 3/4 of the way up that side right there, something like that. Those two vectors influence each other. Okay. So the question here is this: describe the direction and magnitude of the flight vector. Here's your initial point. Here's your terminal point. Okay, and we need the direction and the magnitude. So if you remember back to what we did before, this is 246. This right here is 76. Okay, both are in miles. To get your direction, I need this angle right here. Okay, so again, I hope you see in the right triangle here, you've got your opposite side and adjacent side. So direction is going to be the tangent of x is equal to the opposite over the adjacent. Okay? And I'm going to go ahead and solve for x by using my inverse tangent function. Okay? And so as a result, we get a degree here, 17.2 degrees north of east. Okay, because we're heading north from east. Now, the question I would automatically ask is this: what if I was to go ahead and do the 76 degrees north first, and then from there do the 246 degrees east? Well, the answer is you end up at the same spot. And so if you would have done that and found this angle here, again by using your trig functions, you would just end up with the complement of that. So this would have also been an answer. 90 minus that, 80, 73, 72.8 degrees. And it would just be east of north. Okay. So both are acceptable answers there. It just depends on how you chose to draw your picture out. Okay. For the magnitude, again, the magnitude, we want to figure out how long this vector is. We're just going to use our Pythagorean theorem. So in setting up the magnitude, we end up having 246 plus 7, or squared plus 76 squared is equal to c squared. Okay. And so if we square both of those and add them together, you get 66,292. And then you square root both sides and you end up with approximately 257.5. Okay, and that's going to be, C, actually it should be miles there. Okay, 257.5 miles. All right. So again, just trying to make sure that you understand what a vector is. Okay, you know, like I said before, it's a quantity with both magnitude and direction. A lot of times we talk about how forces act upon each other using vectors, and so make sure that you've got that down. Know how to describe a vector as an ordered pair, both the x and y, how to find that. And then also how to describe the vector using both direction and magnitude. Okay? So you have some practice problems I'd like you to get to, but hopefully that's understandable. If not, come see me and we'll try to work out the kinks. Thank you for listening and have a great night.